Energy data is everywhere, and it's the foundation of nearly every decision we make in the energy sector. Whether we are designing a solar installation, assessing wind potential, planning grid infrastructure, or developing policy, the analysis always starts with one thing: access to data. We use energy data to estimate the production of solar assets, to assess wind speed and turbulence, and even to evaluate how terrain and elevation affect system performance. In fact, many types of geospatial data, from satellite radiation maps to topographic models, can be considered energy data, because they directly inform our understanding of energy resources and infrastructure. However, one of the most important and sometimes most difficult tasks in this process is accessing high-quality open-source data. In some regions, it can be challenging to find any data at all, and in others, you may find multiple sources, and they don't always align, so you can find many big differences between the data sources. This creates uncertainty, which you must understand and manage in your evaluations. Fortunately, a number of excellent open-source databases are available today, especially for photovoltaics and wind. Some of the most widely used include PVU-GIS, which was developed by the European Commission's Joint Research Centre, and it provides solar radiation and PV performance data using both satellite and ground-based measurements. Another tool is Renewables Ninja, which is a platform created by the Imperial College in London and ETH at Zurich, based on global reanalysis data sets like MERA2. Then there is NASA Power, which provides solar and climate datasets, which are very useful for modeling renewable energy systems. ERA 5 from the Copernicus Climate Data Store is a reanalysis model providing long-term meteorological data. The Global Wind Atlas is another tool which was developed by the DTU and the World Bank, and this maps wind resources at multiple hub heights. And then finally there's the GRC Geospatial Energy Industry GeoLab, which combines spatial layers of energy infrastructure and industry. You can also access OpenStreetMap, which is not very energy specific, but it also provides vector data for roads, terrain, land use, and administrative boundaries. And all of these are very useful in geospatial energy analysis. As you see, each of these sources has different strengths and limitations. Some are based on satellite data, others on numerical models. Some offer high spatial resolution, while others offer longer time series. So it's very important to understand their origins and how their assumptions may affect your results. In the following part of the model, we'll take a closer look at the two most commonly used datasets, which are PVU-GIS and Renewables Ninja, and we will show how the data they provide compares, even when all the input assumptions are kept the same.